Welcome to Brunda Engineering Academy. In this video, we will know the information about a hydroelectric power plant. This topic can be utilized for the both civil, mechanical, and electrical students. Electrical also. In case of any competitive examination, like ECET, GATE, okay, or as per our syllabus also. In this video, we completely discuss about what are the main components involved in the hydroelectric power plant and what are the functions of each and every component, and we will discuss about in each and every component what is the function and how they may be asked the questions about these components. Now let us start. Hydroelectric power plant. First of all, hydroelectric power plant means the place where the electrical energy can be produced. Electrical energy can be produced with the help of hydraulic energy. With the help of hydraulic hydraulic energy. Okay, here in this entire chapter, we are having three concepts. One is the three energies. One is the hydraulic energy. Second one is the mechanical energy. Mechanical energy. Now, in the hydroelectric power plant, this hydraulic energy can be first of all converted into the mechanical energy. That mechanical energy can be converted into the electrical energy. Now look at this diagram. This is the basic structure for a hydroelectric power plant. Okay, if you observe this, the components. Here we are having the initial component. Initial component is the catchment area. Here catchment area. Catchment area. Catchment area means nothing but a river. Means suppose the rainfall will be there and the water will be the place. Catchment area means the place where the large quantity of water can be available. Catchment area means the place where a large quantity of water can be available. That location is called as the catchment area. Okay, from that catchment area, we will collect some amount of water, some required amount of water, and store it in particular place. That particular place is called as the reservoir. That particular place is called as the reservoir. Reservoir means some amount of required water can be stored there. Okay, that place is called as the reservoir. And after that reservoir, we will construct a dam. Okay, like this. This is the dam. Okay, the dam is the function of the dam is to control the flow of water. The function of the dam is to control the flow of water from the reservoir. To control the flow of water from the reservoir. Okay, our target is here in any hydroelectric power plant, hydraulic turbines are there. Hydraulic turbines are there. The function of a hydraulic turbines is you have to convert the hydraulic energy into the mechanical energy. Mechanical energy means you have to produce, you have to reduce the, you have to rotate the wheel of the turbine. So our target is always we have to rotate the turbine wheel. So to rotate that turbine, you initially supplied hydraulic energy. Okay. So from the reservoir to the turbine, you have to supply the water. So that type of device is called as the penstock pipe. Generally, it can be taken as the waterways. That waterways or penstock pipe can be used to carry the water from the reservoir to the inlet of the turbine. So it is the inlet for the turbine. It is the inlet for the turbine. So here the concept is penstock pipe can be used to carry the water from the reservoir to the inlet of the turbine. The pipe which can be carried the water from reservoir to inlet of the turbine is called as the penstock pipe. Okay. After that, at the inlet, we are having the nozzle. Okay. After that, here it is the runner, runner or rotor. This circular disc is called as the runner or rotor or turbine. Runner. Okay. After that, on the runner, the turbine blades are there. These are called as vanes or blades are there. So this is about this one. Now this is the turbine, and here the shaded area. The shaded area is called as the shaft of the turbine. That shaded is the area is the shaft of the turbine. This shaft can be coupled with the generator setup. That means that will be coupled with the electrical components to produce the electrical energy. Now, initially, the step is that the hydraulic energy is here because the water can be stored in the reservoir. That is the hydraulic energy. That hydraulic energy will be carried to the inlet of the turbine. With the help of that hydraulic energy, the turbine can be rotates. Turbine can be rotates means there is the motion in the body. Motion in the component means there will be mechanical energy. So the here the shaft can be rotates. That shaft is coupled with the shaft of the generator or electrical components. Then the electrical components will be in the operating condition. Then that will be that will be produced as the electrical energy. So these are the major components involved in the hydroelectric power plant. And with these components, some another components are also there. Like this, if you observe this one, if they observe this diagram, a surge tank is there. Suppose if you observe this diagram, one surge tank, this is called as the surge tank. This is called as the surge tank. Okay, here this is called as a surge tank. The function of the surge tank is, suppose if you observe this in this diagram, here the reservoir is at the higher level, reservoir is at the higher level, and the turbine at the lower level. The water can be carried from the penstock pipe with the help of the gravitational force. With the high pressure, the water can be strikes the blades of the turbine. Sometimes the pressure may be causes the damage to this penstock pipe. So to avoid the damages to the penstock pipe at the location, here we can construct a tank that called as the surge tank. That tank can be called as the surge tank. Here, due to that pressure, the pipe can be vibrate there. That pipe can be vibrates. Okay, that is called as the water hammer. That vibration is called as the water hammer. That vibration is called as the water hammer. So to avoid the water hammer problem in the penstock pipe, we can construct a device that is called as the surge tank. So here the concept is surge tank can be used to avoid the water hammer in the penstock pipe. So these are the components. In the competitive examination point of view, they may be asked each and every component. Catchment area means the place where the large quantity of water can be available. Reservoir means the place we can use it to store the required amount of water. And the dam can be used to control the flow of water. And the penstock pipe can be carries the water from reservoir to the inlet of the turbine. The surge tank can be used to avoid the water hammer in the penstock pipe. Now the hydraulic energy in the reservoir can be converted into the mechanical energy. Now the different concept, the next thing is the here if you observe that now let us move the next step. Let us move the next components. Here three different terminologies are there. One is the head race. Head race is nothing but the top level in the reservoir. Head race is the top level in the reservoir is called as the head race level. Top level in the reservoir is called as the head race level. bottom level in the reservoir is called as the tail race level. This is the tail race level. Now the distance between the head race level and the tail race level is called as the gross head. That means the total level in the reservoir is called as the gross head. The difference between the head race level and the tail race level is called as gross head. Next, here the head race gross head is the Hg. It can be represented in the Hg. Now, some amount of head will be lost at the inlet of the turbine. It is impossible to carry the water from the reservoir of the total water cannot be passes to the inlet of the turbine. So, some amount of water can be lost due to friction. That is called as the loss of head due to friction. HF is called as the loss of head due to friction. HF can be calculated by using this relation 4F LV square by 2GD. 4F LV square by 2GD based on the Darcy-Weisbach equation. In the next videos, we will discuss about this important equation also. Okay. Now this is the loss of head due to friction. But the remaining balance head is called as the net head. Net head. Net head is represented by small h, capital H. That can be simply written as H equal to Hg minus Hf. Net head is also called as the effective head. It is called as the effective head. So these are the important terminologies. Gross head means the difference between the head race level and tail race level is called as the gross head, and some loss of head due to friction will be there. So the difference between the head race and the difference between the gross head and loss of head due to friction is called as the effective head. So in the competitive examination point of view, effective head or net head is also the same. Okay, in the problems also they give directly H value. Okay, head is given. If they want to calculate a gross head, they simply mention Hg. Otherwise, that can be taken as the H. So finally reviewed that in the competitive examination point of view, what is the sequence of order in the hydroelectric power plant? Initially, catchment area will be there. After that, reservoir is there. After that, dam is there. After that, penstock pipe is there. On the penstock pipe, surge tank is there. After that, turbine casing. Here, one more important component is also available. This is called as it is a casing arrangement is also there. Casing can be used to avoid the splashing or spreading of water. Suppose the water will be strikes to the blades of the turbine. After that, the water will be falls in the reservoir also. Okay, in the reservoir. And the formula's point of view, the difference between the head race and the tail race is called as the gross head, and the difference between gross head and the loss of head due to friction is called as the net head or effective head. In the next video, we will discuss about the shortcuts related to the hydraulic turbines. Okay. So if you like this video, please subscribe and share to your friends also.